Hello everybody, welcome to Unit 2, basically. We just finished Unit 1, and now we're going to go ahead and jump into equations and inequalities for Unit 2, and today we're going to be mostly talking about properties. We're also going to do a quick review of 1 and 2-step equations. So, just a reminder, if you missed something, feel free to pause, go back, all that fun stuff. I will be kind of going through these properties a little bit quickly, just because most of it you guys already know, okay? Commutative property is when we change the order of things. What it says is that it's okay because it's still equal. So we have it over addition and multiplication. So changing the order of the addends, which are the things that are being added together. So an example is a plus b is equal to the reverse order of b plus a, and it's still equal. Multiplication, same deal. We're just changing the order of the factors. Factors are the things that are getting multiplied together. So you could do a times b, or you could reverse it and do b times a, and they're still equal. Associative property is very similar in that it's over addition and multiplication. Associative property says that we can change the group. Okay, so whatever's in parentheses, if everything's being added or everything's being multiplied, we can change the groups and basically which one we want to add together first or multiply together first. So changing the grouping symbols, so we could do a plus the quantity b plus c, so that means you do that first, or you can switch it around and do a plus b first and then add the c. Same thing with multiplication, we're just changing the grouping symbols. So here we'd group b and c together, so that means we'd have to do that one first and then multiply by a, or we can do b and a first and then multiply by c because they're equal, so it's allowed. The identity property basically is again over addition and multiplication. It says for addition, if you add anything with 0, you're going to get that same number. Okay, just because 0, you can't add anything with, like you can add with it, but it's just going to give you that same thing. And with multiplication, if you multiply a number by 1, you're going to get that same number. So it's just meaning that the number is not changing because of what you're either adding to it or multiplying with. Okay. Inverse property, which is going to be a big property you're going to see a lot this unit, again over addition and multiplication. And the reason it's only addition and multiplication for all of these is because, like we said, with addition or subtraction is really adding a negative. So even subtraction we can lump in with the addition. And same thing with division. When you divide by something, you're really multiplying by the fraction of that number, like here, like 1 over that number. So when you're talking about division, you're really talking about multiplication here, and you can swing it that way. So inverse operation just says that when we're adding, if you add a number with its opposite, meaning the different sign, you're going to get 0. You're going to get that identity element, the 0 that we worked with up here. Okay, and with multiplication, that if you multiply a number with its reciprocal, meaning making it into a fraction or flip the fraction, it's going to equal 1. So the sum of a number and its opposite equals 0, where the product of a number and its reciprocal, its flip of the fraction, equals 1. Okay, and the distributive property we've kind of already done, so it's just meaning you're multiplying with everything inside the parenthesis. And this is only done when inside the parenthesis is either adding or subtraction. Okay? We don't bother doing it with multiplication or division, just adding and subtracting inside the parentheses. And the last one, I don't know if this is on your notes, but multiplicative property of 0 just says if you multiply a number with 0, it's going to equal 0. It will always equal 0, no matter the number. Okay? Moving on. So these ones are new, okay? And it's good that you know them. So reflexive property, most of these you already know because they're like common sense. It's just now we're putting a name with it. Reflexive property says that a number is equal to itself. So A equals A, obviously. But now you have a name for it, the reflexive property. Symmetric property says that you can flip the equation around. The order of equality doesn't matter. So you can have A equals B, or flip it and say B equals A. Okay? Now transitive property is a little weird. And it's wordy too. It says if two numbers equal the same number are equal to each other. So here's an example. If A equals B and B equals C, so that means B equals both A and C. A and C are equal to each other then. So it's kind of like a train stop. If you go from DC to New York and then New York to London, you really went from DC to London. Okay? And we can talk about this more in class. Substitution is basically just if you replace a number with something it's equal to, or you replace an expression with something it's equal to. We need to know these properties because now when we solve equations, we have to justify our steps, and we're going to use these properties to justify it, saying that this is okay that I do it because this property says so. So when we do substitution, a lot of the math that you do, like 4 plus 3 equals 7, that's substitution. Combining like terms is substitution, okay? And then these last 4 are probably the easiest. It just says if you do something to one side, you have to do it to the other side to keep it equal. So addition, property, equality, if you add something to one side, so we added a z to the x here, we have to add the z to the y as well, so it remains equal. Same deal with subtraction. You guys can abbreviate these notes because I know it's very wordy. If you're going to subtract z from one side, you have to do it to the other side to keep it equal. If you're going to multiply by z on one side, you have to do it to the other side. If you're going to divide by z on one side, you have to do it to the other side. Okay? So let's practice some 1 and 2 step equations. Now, when we talked about simplifying an expression, what we did was we found the value that the whole expression was equal to, a single number. With equations, that equal to part, like equal to 4 is the value of the expression. Now we're working backwards and trying to find that missing piece. So it's just, yeah, we're just working backwards. All right, so to solve an equation, we must isolate the variable. So we're trying to get that by itself. And because we're working backwards, we undo the operations. And we do it in the reverse order of GEMDAS. So because we're undoing stuff and we're going backwards, we just reverse it. So to undo our operations, we follow a specific order. Instead of GEMDAS, we reverse that and we get SADMAG. So we start off with undoing subtraction and addition. Anything added or subtracted to the variable, we undo that first. And by undoing it, we just use the opposite operation. So if it was added to it, we subtract it. If it was multiplied, we divide it. And then once we've done all the subtraction, addition, then we can undo anything that was multiplied or divided with the variable by doing the opposite operation. Then we can undo any exponents on the variable. And finally, the last thing, if the variable is in a group, so if it's in parentheses or if it's in like part of the fraction, then we're going to take care of that whole side last. And so our new order actually spelled out SADMAG. Meg is sad because we're trying to find her x. She doesn't know where her x is or what it is. Okay, so let's go ahead and practice some of these. So here's some examples. So here, the first one, 4x equals 1. The only thing that's happening to the x is we're multiplying by 4. Okay, so because we only have one operation happening to it, we can undo that. To undo multiplication, we divide it by 4. So we have to just divide this 4x by 4. When we multiply and divide by the same number, they cancel each other out. And because we did it to one side, we have to do it to the other side as well. So the 4's will cancel out, leaving 1x by itself. And 1 divided by 4 is just 1/4. And we can simplify it further just by writing what x is. X equals 1/4. Okay? Now here in this example, we have just one thing being multiplied with the m. That's the 4/5. So we could divide both sides by 4/5, just like we did with the 4 over here. So then the 4/5 would be canceled out because we're multiplying and dividing by it. So they undo each other, leaving us with 1m. 28 divided by 4/5 is 35. And then we just write m equals 35. Another way you could do it, because you remember you're trying to make this into a 1m, you could multiply this fraction by its reciprocal. Okay? So the other way is, instead of dividing by 4/5, you could multiply both sides by the flip version of it in 5/4. 4/5 times its reciprocal will give you 1. And 28 times 5/4 will also give us 35. Okay? So we still get the same answer. It's up to you. This is the way I'm probably going to show you more in class. Because this gets a little dicey when you're dividing by fractions, especially in the calculator. So just be prepared. Just understand they mean the same thing. It's just this way is a little bit cleaner. Okay, and then two-step equations where we have two operations happening to the variable. So here the r is being multiplied and we're adding 1 to it. So according to Stat Meg, we have to undo this plus 1 first. So to undo that, we subtract 1 from both sides. That way the 1 minus 1 will cancel out, leaving us with 3r equals 15. Now we can undo this multiplication by dividing by 3. The 3's will cancel out here, leaving 1r, and then r equals 5. Okay? And the last one here, x is being, we're subtracting 7. Oh, sorry, that was the bell. You guys are all leaving school right now, so if you hear a lot of chatter, it's just because you guys are all running down the halls. But alright, so x, we are subtracting 7 and we're dividing by 3. However, because it's a fraction bar, this x is actually in a group. So we're going to undo this divided by 3 because this is not really 7. This 7 is being divided by 3. So in order to deal with that 7, we have to get rid of this divided by 3. So we're going to multiply both sides by 3. Okay, that way the divided by 3 and times 3 cancel each other out, leaving us with x minus 7 and negative 36 over here. So now I can undo this minus 7 by adding 7 to both sides. The 7's will cancel out. I add 7 over here. I get x equals negative 29. And I can leave it like this, or I can use the symmetric property and flip it so it says x equals negative 29, like that. Okay, so you guys are going to try these four on your own. You can either pause the video or come back to it. Okay, but we're going to go ahead and go on to the next part, which is how to write your answer. Now, set builder notation is a way of expressing your solution, which is the answer to an equation. Sometimes you get one number, like x equals 4 or something, but sometimes x can be a lot of different numbers. So we use set builder notation because it's a set, and a set tells us like everything we can include in there. So the way we write it is literally like this: the brace, a variable, a line, and then our answer. So we just go ahead and write it like that. The sets, the way we read it is it's a set of x's such that x equals whatever number. So the reason we write it this way is because we want to say this set is including every x as long as, that's what the such that means, x is equal to this number. Or we might put something different like x is greater than 3 or something. Whatever rule we have to follow for it to be a solution. Okay, I know it seems dumb right now because we only have one number that can work, but later on in this course and in future courses, you could have multiple solutions, so you want to be able to write this. Okay, so example 2, we're going to go ahead and try to write our answers that we got in set builder notation, and we literally just copy this down and put in whatever x is, or change the variable depending on the variable for the problem. Okay, so x equals 1/4. We're just going to write it's the set of x such that x equals 1/4. So we just put braces around, add an extra variable, and a line in there. That's all we're doing. Here, because it's m, we're going to use m's in our set builder notation. So it's a set of m such that m equals 35. Okay. C, it's a set of r such that r equals 5. And D, a set of x such that x equals 29. So the only thing you need to remember is the line, that extra variable, and then the braces around it. That's the only extra stuff that you're going to have to do to put it in set builder notation versus just writing the answer. Okay? Now the answers you got on the last try on your own, I want you to try to write them in set builder notation. Okay? So give that a go. And then we're going to do this last problem, and then the video will be done. Yay! So part of knowing the properties is being able to justify our steps. So a lot of the problems you're going to see is actually someone's already done all the work, but we have to give a reason why they were able to do that. Why could they subtract 8 from that side? Okay? And we use our properties to justify that. So here, we start off with 74 equals 8 plus 3b. That was the original problem. Okay? Then the next step, the only difference between the first one and the second line is this minus 8 on both sides. So when we subtract 8 from both sides, that's a subtraction property of equality. We took it away from one side. This side was our main focus because we're trying to get b by itself. We also had to do it to the other side. Then we switched the 8s around a little bit. We changed the order here. So we moved the 3b and the negative 8 around. And that was our commutative property of addition. We were able to change the order. The next thing we did, we did a couple things. We went from 74 minus 8 to 66. Okay? We replaced 74 minus 8 with 66. That was an example of substitution. Okay? Substitution is kind of the secondary thing that happened. It's not our main focus because it wasn't about the side with the v on it. Okay? Now, sometimes that's something you might have to put in. Most times, this is the side you're going to focus on, this property, because we went from 8 minus 8 plus 3b to 0. The 8 minus 8 that canceled out and became 0, that's an example of the inverse property of addition, because we had a number plus its opposite. So a positive 8 plus the negative 8 here creates that 0. That's the inverse property of addition. So you can also, if you want to, put substitution in there, just so, like, you can let me know I knew that was substitution. That's fine. Okay. Then we went from 0 plus 3b to just a v, 3b over here. So we got rid of the 0. Anything plus 0 gives us itself. That's the identity property of addition. Okay. And then down here, all we did was divide by 3 on both sides. That's the division property of equality. And then what we did, again, here, 66 divided by 3, we replaced that with 22. So that's substitution again. But again, that's kind of the secondary one. The v side is what you want to focus on. We had 3v divided by itself and just got the v. What happened was we actually did the inverse property, because and we'd say it was a multiplication, because when we divide by 3, it's the same thing as multiplying by 1/3, the reciprocal of the 3. Okay, so that's actually inverse of multiplication. And again, you can write in the substitution for the other side. The 66 divided by 3 gives us 22 if you want to, but inverse is what the main focus should be. Okay, and you guys are going to try this last one on your own. Just try justifying steps. We'll go over it, don't worry. But that's it for the video, and I'm pretty sure this was the first one. I forgot to put audio, but this one was shorter, so that's why we're going to put this one up instead. If you guys have any questions, write them down. Otherwise, I will see you next class. And that's it. See you guys later.